Welcome back, everybody. It's wonderful to welcome Mark Prince. I don't think anybody has ever spoken to us from as far as California, so that's the first. It's a big pleasure to introduce Mark Prince. He's in fact a CEO of a company that a friend of mine works for, and we met with her whilst climbing Mount Ararat in East Turkey. So that's how Mark Prince's attendance came about. So without further ado, Mark, over to you, please.
Thank you. It's a great privilege to be here. And I have to first provide one disclaimer. It's still not anyone speaking from California. I am in fact in Boston, Massachusetts. But while the company Cardio is headquartered in California, I work from a home in Boston. But it's a pleasure to join everyone today and a real pleasure to be here. My presentation today is about an update from Cardio's experience in the pandemic and what we call the front line of remote patient monitoring. I'm going to try to share my screen to share a presentation. Hopefully the screen share will work. Could you let me know if you have this?
Yes, perfect.
Excellent. Okay. So I'd like to discuss what our team's been doing in digital health and what we see on the horizon for connected care. First, I'm going to provide a quick introduction to Cardio and who we are, just for some context. So our company was founded primarily to address cardiovascular disease. I'm sure most, if not all, of the people participating in the conference today know that cardiovascular disease, or CVD, is the #1 cause of death globally. It takes almost 18 million lives annually, according to the World Health Organization. And in England alone, it's an annual cost of £7.4 billion annually. Cardio addresses this segment with a remote monitoring solution for an ambulatory ECG. Now, next. Our solution is a cloud-based service with a cardiology focus. And our service portfolio includes remote monitoring applications for primary care and chronic care. And our platform, which is called CardioMD, provides real-time analytics for clinicians. And when it's used in conjunction with UK-based cardiology partners, our service provides validated reports within 24 hours. Compared to many other ECG services and analytics services today, this is a big leap forward. And the system relies on our apps that run on smartphones, which generally relay the data via mobile networks to the Cardio cloud. And in turn, the data can be accessed by care providers via any internet-connected device, a smartphone, tablet, PC, etc. The platform's been developed to provide operational efficiency. It's designed to be intuitive with very large patient data sets and also scalable for large patient populations. The way it works is we've received diagnostic data from Cardio's proprietary diagnostic devices. One is Cardio Core. It's a ECG with no wires, no patches, no adhesives, no skin prep. And this device also records other vitals, such as skin temperature and respiratory rate. Cardio Arm is a wireless blood pressure monitor. And in addition to recording blood pressure, it also has an irregular heartbeat detection feature. And its compact form factor means it's well suited to be used for ambulatory blood pressure monitoring, which can be implemented with our remote monitoring capabilities. And we also have a Cardio Base, a weight and body composition scale. So I show you this picture of the calendar from the beginning of the year. It's not a time that I like to dwell on or think about much, but this is, of course, when the pandemic began and became very clear to us. In March, as the pandemic was taking hold in the US, one of our partners, Dr. Tro, runs a private practice in New York City. He told us that cardio helped him adapt his care model overnight, literally overnight, so that he could continue to monitor at-risk patients in their homes. And the practice successfully transitioned to a 100% remote patient care model and remained open throughout the entire quarantine period. In this way, remote patient monitoring, it can extend and enhance a pure telehealth play, such as audio and video service. And in addition to providing the simple consultations that you can do with telehealth, remote monitoring enables providers and patients to engage in a much more meaningful way using real-time diagnostic data so that you can spot changes in baseline trends and take action and triage. Cardio's combination of connected devices and cloud-based services enables GPs and all kinds of care providers, all kinds of clinicians to stay engaged even when patients are unable to visit a clinician and to sustain critical care without disruption. And by distributing diagnostic devices to the patient, we can open up a wide range of new applications, which I'll talk about in just a moment. So one of the things that we did during that time period was we started to study how things were changing. And we completed an internal study. And what we noticed was, as you can see on the screen here, a significant percentage of care providers saw disruption as a result of COVID-19, over 85%. 87% reported that they intended to increase an investment in telehealth. 91% observed an increase in patient confidence related to the use of technology at home. 96% as a result of using our platform intend to encourage more remote monitoring. And almost 100% reported that blood pressure monitoring is very important in the future. This is why we see the potential of remote monitoring as a new standard of care. It's based on continuous patient engagement. Rather than ad hoc or a la carte services, this type of remote monitoring service based in the cloud can enable care providers to stay engaged and even improve engagement in ways that have never been available before. We also see that as based on the survey results we received, providers and patient attitudes are changing quickly, and we're very well positioned to adopt new technologies. Technologies and the associated interfaces have matured to a point where minimal behavior change is needed in order to implement a new solution. In addition, in a survey of over 5,500 cardio users, 93% felt safer with a device at home, and they recognized the benefits of having such a system. Over 80% of the patients believed that having remote blood pressure monitoring would save time for them and for their provider. No more trips to the clinic, no more waiting to be seen, no more queues, no more time away from work or from family. So what about the future? If anything, the pandemic has brought telehealth into focus, certainly in the United States, increasingly in the UK, but we also see very, very strong uptake of cardio services worldwide. It's clear that real diagnostics must be incorporated with audio and video. So telehealth is out in front, but remote monitoring is a natural extension of telehealth. And remote patient monitoring can extend telehealth and provide the meaningful diagnostic information for a clinician under any conditions. So even as we see now, where we're seeing the second wave of the pandemic continue, it's increasingly important to maintain this engagement. It also provides buffer for overflow to keep people out of hospitals and out of clinics during surge conditions. We believe that primary care must have continuous monitoring capabilities to make sure that patients remain safe, especially chronic care and elderly populations who should not be brought into a clinic or any medical setting unnecessarily, especially if there's a pandemic underway. So providing care providers with this data is the only way to avoid acute failures at the individual patient level and to ensure continuity at the system level. This enables care providers to triage much faster and to make meaningful gains in care delivery and patient outcomes. This is what we've learned over the last 9 months, that unfortunately we are the beneficiaries of the pandemic, where we have a solution that is very useful. And so it's a little bit with some guilt that I share with all of you today that remote monitoring is in fact something that we see as a critical piece of care provision in the very near future. In fact, cardio partners today are benefiting immediately. So that said, I'm glad to take any questions people might have about cardio or about remote monitoring in general.
Well, Mark, thank you so very much for this really fascinating and timely presentation too. Can I just kick off the questions by just asking you, do you think that our world has changed for good, or will we be going back to the pre-COVID state?
Personally, I think the answer is both. This has been such a massive disruption that I think that there are going to be lasting changes. But I also know that behavior change is difficult for everyone, every country, every practice, and so it takes time.
Anna, please.
Hi. So first of all, yeah, thank you for your talk, and it has been really, really interesting. And I guess my question is more general towards like the trend of patient monitoring and data collection. Is that we generate a lot of data, and it has to be protected in some way, and it has to be managed in some way to ensure that it's not used improperly. So what do you think would be the next steps for us to manage that?
Yeah, thank you. So there are, I'm sure you're well aware, broad regulations and policies that already apply to companies like Cardio. We're a global company. We're a US-based company, so we start with HIPAA compliance, and then the general privacy guidelines for the EU, GDPR, apply as well. So we look at individual patient data as well as the specific data policies of our partners, which can be hospitals, they can be governmental health agencies, and we develop plans accordingly. The bottom line is, I'm sure everyone's well aware, our friends, Google, Microsoft, and others have already done quite a bit, Amazon, especially with Amazon Web Services, to ensure that there are very robust infrastructure solutions in place for making sure that data is protected. Of course, we're really a startup company. And so we need to make sure that we're using services, utilizing third-party services and resources that are fully compliant and secure. And that's part of the liability to our business, especially as an American business where liability is always a huge issue. I am fairly confident that Cardio is taking the right steps. in each market in which we participate to make sure that one, we're compliant with regulation, but two, that we're going beyond just regulation to ensure that our partnerships respect the data ownership rights of both our partners and their patients.
But I guess it's with anything, it's a double-edged sword, because in some way it's also true that the access to such huge databases can potentially foster a really great research for scientists to spot the trends that which wouldn't otherwise be possible.
Absolutely. You know, one of the interesting challenges is how to align the metadata. So even when you de-identify the data and you're just looking at objective patient data sets, how do you align Cardio's ECG data with another third party's ECG data? It can be done. It's a very interesting challenge, but I think that there's a big opportunity in your question to look at these very large data sets. And that's clearly why entities like Amazon, like Apple, are quickly moving into healthcare because they have great resources to look at some of the largest data sets.
And do you truly believe that the data can be completely de-identified?
This might be naive answer, but I believe the answer is yes, it can be. The question is, will it be done consistently and accurately when we attempt to do such things?
I see. Because I believe if you combine different data sets that track different things, and then you look for coherence between them, you might be able to still identify it, but I don't know. That's just...
I guess it depends on the agenda of the researcher. If they're truly looking to see biometric data, in theory, they're not working so hard to try and identify individual patients. It would be a concerted effort to get the individual patient identifier to correlate with the particular data set. But can it be done? I'm sure we both know that there are some very talented people who could work on that goal. The question would be, do we take the right precautions? And my answer from the American company side is yes, of course we try.
I see, thank you.
Yeah.
I'm just checking if people have any further questions. If not, just the final, very brief, Mark. What lies ahead? How do you see the prospects of the future home monitoring? What do you think?
So thank you. So I see some tension between. Well, let me take a step back to answer the question. Basically, all industrialized nations have the same problem, which is increasing healthcare cost. All of them. And our solution has the potential to bring great efficiency. And in the US, we talk about value-based care models that reduce cost. However, at the same time that we're introducing efficiencies, improved patient workflow, earlier interventions, preempting the need to triage catastrophic patient failures because you've had earlier interventions that have better patient outcomes. All of these things reduce cost, but they come at a cost, which is the cost of deploying health hardware and technology in order to have access to this data. And so I see this as a challenge in some very rich countries. I see it as an even bigger challenge, of course, in countries where the economy might not be quite as robust as the US or the UK or the EU. And so I see a real challenge in getting to the future where we can very efficiently and economically get access to the data that can make the big difference in terms of how care is delivered for better outcomes. But I believe we're all moving in this direction. Digital health has the potential. The widespread adoption of this device is what's going to make a huge difference in basically all Western markets, all industrialized markets, because once the patient has the ability to start tracking some of their basic vitals just through the device, we're already making huge gains. And what's been said, not just in CVD, but in heart disease and high blood pressure in general, is always know your numbers. Knowledge is power. And the thing that digital health does is it gives the patient knowledge. It's education and empowerment. And so I have great conviction that digital health will bring more knowledge and empowerment to the patient, and thereby also improve the opportunity for the care provider as well.
Thank you, Mark. Thank you for your time and for sharing your thoughts and the prospects for the future with our community. And it was a great pleasure to host you. Thank you.
Thank you so much. It's been a pleasure to be here. And I also, I'll leave on one note, which is to say that Cardio works with some teams in Ukraine on the development side. And so we have a direct personal connection with Ukraine. Anyone who looks at our app, anyone who looks at our service is looking at some work that's been performed in Ukraine. And so we appreciate that very much.
Wonderful. Thank you. Slava Ukraini, as they say.
Thank you.
All right. Cheers. Thanks, Mark. So our next presenter is Anna Tarasenko, who was really key in helping to set up this conference, and in general has shown herself to be a very multi-talented colleague, including amazing graphic design skills as well as skills in neuroscience. So over to Anna.
Thank you, Dennis, for this very kind introduction. Let me just show the presentation. Can you see it now?
Yep.
Okay, perfect. So yeah, my name is Anna, and I am a neuroscientist from a neurotech startup based in London called BrainPatch that designs a device that aims to deliver non-invasive stimulation. And today I want to talk to you about the technology of brain stimulation. So the agenda for my today's talk is the introduction to brain stimulation. Then I'll talk a bit more about BrainPatch and what we do and who we are. Then I want to mention the existing stimulation technologies that are presently on the market and how they are used. This will bring me on to challenges which are associated with any neurotech device that exists, and our solution as we see it in BrainPatch. Every man, if he so desires, becomes sculptor of his own brain. We can intuitively understand this in relation to the way how our brain gets shaped by our experiences, by our interactions. But also, unfortunately, another thing that shapes it are multiple neurological disorders that directly affect the activity in our brain. And classically, we overcome this through the use of medications, which are aiming to change the brain chemistry and therefore potentially restore the dynamics to what it should be. However, because of the nature of the drugs, they often have a very broad spectrum of action. So therefore, they have different side effects. Some are less, some are more. But as a result, we have an alternative approach that has been developing for quite some time and has been mentioned before, which is electroceuticals. So the idea behind electroceuticals is that we use electrical current to directly modulate the brain activity. And this is exactly what we're trying to do with BrainPatch. We try to create a device which will be able to act on the existing dynamics and alter it in some way or another through the use of electrical current. However, I will come back to this a bit later. So broadly, the stimulation can be divided into invasive and non-invasive. And we've heard today about the invasive part of the stimulation, which is essentially involves insertion of the electrodes inside the brain to stimulate a particular brain structure. And this technique has been used successfully used in a range of disorders such as epilepsy, and has been shown to reduce tremor in Parkinson's and was a great success, which later on led to a development of non-invasive brain stimulation, which is essentially just applying the electricity directly on the scalp. Intuitively, it is much less precise, but also less invasive. So depending on the stimulation sites, we can target different diseases. So it's possible to target the brain structures such as the dorsolateral prefrontal cortex, the so-called cognitive center, the ventroanterior cingulate cortex, which is a more of an emotional center, and motor cortex. These are the sites that tend to be most used with the non-invasive brain stimulation. But also a very interesting and promising area is the cranial nerve stimulation. You can see at the bottom of the brain, there are these yellow lines that innervate a great number of structures in our body, and therefore the cranial nerve stimulation has also been shown to be very beneficial in the disorders beyond the disorders of the brain. In particular, the vagus nerve stimulation that was again mentioned earlier, but it was an invasive vagus nerve stimulation, which involves insertion of the stimulator into the vagus nerve. However, the non-invasive vagus nerve stimulation has been also used, and in particular has been approved as an alternative treatment for migraines. So it's clear that these technologies have a wide market potential, both clinical and non-clinical. But also, there is a high element of immersive market with the use of virtual reality and gaming aspect. And it's, as we can see, the market size for it and the value of the market for these technologies is much higher, but it still generates the tremendous amount of research and knowledge that can be later used for clinical as well as non-clinical purposes. So now I want to talk a little bit about the devices that are currently present on the market, the clinical grade devices. And if you look at them, you can see that the stimulation that they provide is very often either tailored to a particular structure like Soterix Medical. You can see there that stimulates just a single site, which is the dorsolateral prefrontal cortex, or is tailored to a particular type of stimulation current, like direct current, not the alternating current. And so all of them are very specialized towards a particular type of stimulation, and generally have a very, very high cost associated with them, and therefore are not particularly widely available. At BrainPatch, you can see at the top right corner, this is the device that we're working on. At the moment, we try to unite this functionality all in one through the use of, so that we can both combine the EEG tracking, which you see on the top left corner, that's ridiculous price and strangely looking equipment, but it's still very, very good and very precise with the stimulation as well as the machine learning algorithms. These are the consumer brain stimulation devices, which are currently present, which are not clinical. So they are used for concentration, for motor enhancement, and similarly to the clinical devices, they tend to be very specifically tailored to a type of stimulation or to a type of problem that they are targeting. So there are, despite like all this research and all these devices, there is a wide range of challenges associated with the area of brain stimulation. And the first very obvious one is that the mechanism of action of the stimulation is still somewhat unclear, because we have we tend to observe certain effects of it, but we are not sure how exactly it causes those effects. For example, it is believed that brain stimulation increases the firing probability of the neurons in the stimulated area. as well as it increases the probability of new connections forming in this area, which is termed plasticity. But we're not sure of how exactly that happens. So therefore, coming forward, it's very important to conduct more vigorous systemic research into that, and in order to understand it better. And recently, a important development in this area that brought us a whole new question is the network effects. So it was shown that, in fact, the stimulation, while being localized to a particular area, causes a lot of downstream effects in the structures downstream from the stimulated structure. And therefore, it's very important to understand what are the connections of the networks that are present. And second challenge, which is obviously related to the fact that it's a non-invasive stimulation, is the precision of the target site, that we can't really never be exactly sure about the fact that what exactly we're stimulating. And currently there are fMRI studies being conducted to try to understand what areas are trying to be activated and to find the best position of electrodes for the stimulating of different sites. And one of the main reasons behind those challenges in the field is that majority of research that's being conducted is not systematic, in a way that it's not, the profiles of the stimulations that are used is different. So the intensity of the current that is being used, the electrodes, the position of electrodes, as well as the regimen, i.e. whether we apply stimulation once, one-off stimulation, or whether we apply it regularly. And therefore, it's really hard to create a meta-analysis of the data. And one of the reasons behind such heterogeneity within the research is that also there is a high degree of individuality to the reaction of the stimulation, because, as I've mentioned, the networks effects, so at any given moment, there are different networks active in our brain. And it really depends on the state of where we're in, how much did we sleep, what we're thinking about, and that brain activity at that particular moment will define how we will respond to the stimulation. So this is the third challenge, the personalization of the stimulation. And this is exactly what we're trying to address at BrainPatch. So we aim to create a closed loop system which will analyze the state the brain is in through the analysis of the EEG data that is being recorded. And based on that, we'll suggest a personally tailored stimulation regimen in order to achieve, whether it being in concentration or relaxation, depending on the aim. At the moment, we have achieved some progress in that, in the identification of the brain states through the EEG. It requires obviously the preliminary training of the model. However, the closing of the system, the closed loop nature of the system, is still tricky, because the simultaneously recording and the stimulation is a challenge because of the hardware. So you need to use the same electrodes potentially for the recording and the stimulation, and obviously the stimulation creates a lot of artifact on the EEG. And this is the problem that we're currently trying to solve. But altogether, we believe that electroceuticals potentially can offer a great alternative to the medications for those who cannot take them, either because of their resistance or because of the side effects, or particularly for the pregnant population, in which case they're very sensitive towards the all sorts of drug medications. So, but at the same time, we're also think that it requires further research into the field in order to move it forward. And this is our core team who works at BrainPatch, and our co-founder, Dr. Nikolai Sokov. And I would like to thank you to all of the organizations that make our work possible. Thank you.
Thank you so much, Anna. I mean, it's so wonderful to see this work from somebody who is actually really very young, and I can think about a lot of very experienced researchers who will have achieved a lot less than you have up until this point.
Thank you, Dennis.
Let me just kick off by asking you, in terms of so I think one of your questions to one of the presenters was very good in terms of the prospects of implementing this technology widely. I mean, what do you think are the advantages and disadvantages, perhaps problems and opportunities there?
So I think the advantages are that it's really easy technology to administer. So the stimulation is really, we're trying to create it so that it doesn't require any gel electrodes like putting on the head what you usually do with this ECG. So we're trying to make it as user-friendly as it's possible so that it's easy to administer, or you can give it to the participant and they can do it at home. And also we're developing an app which would be where the participant is able to log their symptoms and their feelings so that we can analyze them remotely. The challenges that associated with it is obviously, as with any new technology, is that we need to, so obviously in order to show its efficiency, you need to work with the clinicians, and in certain cases, as we, for example, experienced with our work with COVID-19, is that we have some idea or potential, but obviously the clinicians are reluctant to try it because there are things that work, the drugs that work. So they don't see why they would try this new technology that hasn't been tested yet, and instead of something that works. So it's that, I guess, and it's understandable on one hand, but on the other hand, you need that kind of paradigm shift if you want to move forward.
So essentially, more research is the answer.
Yeah.
Roman.
Thank you, Anya, for your presentation. It was really interesting to hear. And I have one question. I understand that you collect data from EEG, but my question is that our body not related only to our brain activity, but also related to the activity of our humoral factors, and which I think play significant role in our bodies. So do you reflect on humoral factors like hormones in your research, or you really focus on recording EEG activity?
Well, no, I think I completely agree with you that there are multiple biomarkers that definitely can provide us more insight, but it's just EEG is something as non-invasive that we can track. And we recently we also started working with ECG to work on the heart rate, to analyze the heart rate variability in a person, to look at, because that tends to change when the person is stressed. Also, we'll look at the galvanic skin response, but moving into the future, we're trying to incorporate as many biomarkers as possible in order to get a more holistic picture, as you suggested.
Thank you. But do you think at this point to intervene into human body with so little information about, you said there's a problem that they apply to individual patient, it would be some difficulties, but to apply your result of limited results from your EEG at this point to stimulate different patient, not know directly and fully about this patient, do you think is there any problems with that?
Obviously, yeah, it's an excellent question, and I think that the research into the possible side effects of the stimulation is definitely a needed one. And the thing is that we rely on the technology of the non-invasive brain stimulation involves passing of a very small current intensity, and there have been meta-analytic studies to analyze the side effects of those technologies in healthy volunteers, and so far the results are very promising in a sense that there have been no persistent side effects. The side effect that were reported was skin irritation because of the current, but that would go away very quickly. And sometimes, in minor cases, a headache that again will go away. But the percentages of those reported are quite small. But as you quite rightly suggested, it's very also dependent on the current. So that's why we're currently in the process of organizing a safety trial for our device, where we'll look at the healthy volunteers prior to looking at any clinical population to see if there is anything reported.
Okay, thank you very much and good luck with your project.
Thank you. Thank you very much, Anna. Thank you, Roman. And we are moving on to our next presenter, who is Irina Kuznetsova. Irina will talk to us about something which is really very topical in Ukraine, which essentially is the mental health of the internally displaced people in Ukraine. Over to you, Irina.
Thank you very much again for the invitation, for the opportunity to speak here. I'm a social geographer and sociologist, and I worked closely with our School of Psychology and consultants in Ukraine who study mental health. So let me share screen to show the presentation. Thank you. We conducted this research together with Professor Oksana Mikheyeva from Ukrainian Catholic University, from John Catling from University of Birmingham, Svetlana Babenko from Taras Shevchenko State University, and John Round from Birmingham. As you know, forced displacement from Ukraine, war-torn territories, Donbass, and from Crimea, one of the biggest problem currently in the country. So overall, there are over than 1,500,000 displaced people, mostly from southeastern part of Ukraine. And here you can see a map where people resettled. And despite that, now, you know, there are 6 years past from the first wave of displacement. You know, the issues which people experience, the trauma and the everyday difficulties still affect the mental health. So initially, you know, when I started study Ukraine as a social geographer, we had a project funded by Art and Humanities Research Council in Ukraine, and we studied social consequences of population displacement in Ukraine. So we studied people coping tactics, and also the role of NGOs, the role of state, and then the social citizenship in Ukraine. And as you see, the structure of displaced people in Ukraine is very specific. So Ukraine has the largest portion of elderly affected in the world. And so they're a big part of pensioners who were displaced, and also, you know, comparing with the population structure in government control areas of Ukraine. So as I mentioned initially, when we started our project in 2016, we didn't particularly look for mental health implications, but then doing interviews and just our conversations with displaced people, we realized that how mental health of people were affected. And people shared their stories and, you know, and mentioned that even when they wanted to receive specialized help, as you could see from these quotes from interviews, sometimes even psychologists were not able to understand them. So people mentioned anxiety, people mentioned insomnia, and probably you know how much physical health have been affected as well, and it's a different story. So people who were injured by war, they're still not considered as veterans of war, so they have to rely a lot on charities, on friends to receive therapy and recover. But talking about mental health, there are some projects which existed in Kharkiv, in other eastern parts of the country, in Kyiv, but they're not on a temporal, not on a permanent basis, unfortunately. So, and at that point, we decided that we need to study in depth the issues of mental health of internally displaced people. And we are familiar with the results of the study which were conducted by the London Institute for Tropical Medicine, but they studied only IDPs, but we decided to compare both IDPs and the general population in Ukraine. So in the study was supported by our institutional fund of Birmingham via Wellcome Trust, and included a qualitative study, interviews with experts and with IDPs, key informant interviews, and national survey, which included 1,000 IDPs and 1,000 general population, representative sample, which and the survey was conducted by Lviv agency Socio-Inform 2 years ago. And I'm always happy to speak at the conferences because the process of academic publications takes a long time, but we just want to share our data widely as much as possible. There were limitations of this study, of course, because first we studied only the mental health of adults. The sample didn't include occupied territories. We didn't explore in depth the alcohol and drug consumption. And also it was difficult to differentiate the role of displacement and daily stressors in depression and anxiety of IDPs. And it was outside of the project scope to explore the financial and decentralization aspects in healthcare. So we didn't have a specific focus on public health aspect either. When we asked IDPs and the general population about health issues which affect their daily life, you could see that mental illness were mentioned just by a few informants, 1.2% of displaced and 0.3% of the general population. So people were mentioning such a traditional issues as mobility issues, especially if we talk about elderly people, issues with hearing and some other health problems. But then when we look at data regarding anxiety and depression, and we used GAD-7 for anxiety and PHQ-9 for depression, we validated these scales in Ukraine. So we conducted some pilot studies before we introduced these questions. So, and then we could see the massive differences in anxiety and depression among IDPs and the general population. So 20% and 2% of IDPs experience moderate and severe levels of anxiety, while 12% of the general population experiences. And regarding depression, we can see the prevalence of depression among the IDPs on a clinically significant level compared with the general population. And then when we compared it with the data from the UK surveys, we could see even bigger difference. And then in our recommendations, we argued that it's impossible to target only the IDPs, while the situation of provision of mental health services is really worrying in Ukraine. So there is a need for a complex and holistic approach for that. Here is some scores also just to demonstrate data which I showed on the previous slide. If you talk about seeking help, interestingly, that over 1/5 part of the IDPs, they tried to access mental health support, while non-IDPs, the general population who suffers from depression and anxiety, just less than 1/10 part of them applied for special help. And we can explain it by the fact that IDPs, some of them were informed about specific services and help available, and there were some programs supported by the international organizations, while the general population very often was not informed about such opportunities. And also we can talk a lot about the mental health stigma. We didn't allow people to even to think about applying for special help because of this remembrances about how much mental health has been stigmatized during Soviet time, for example. And also we discovered gender differences, especially in anxiety. So when we look at moderately severe or severe anxiety among IDPs and non-displaced population, so the females have a higher level of anxiety. So, and when we looked back on our interviews with the displaced women, we could partly explain it by the the huge pressure which women experience, including carrying responsibilities and seeking a job and thinking about the house and displacement. And then they have a less variety of coping tactics as well, which I will mention later. At the same time, I will call it, so when we analyzed the coping tactics, what people usually do when they feel distressed for a long time, there are not much differences between the general population and IDPs. So the most common tactic is talking to friends and family, to watch some films or listen music, walking, hiking. A church plays an important role, especially among elderly population, gardening. And then when we talk about gardening, I remember in interviews how much many of the displaced people were missing the dacha, the summer houses, because displacement means not only loss of home, but loss of this everyday routine, what usually contribute to good mental health. And then there are some varying tactics as well and strategies. For example, almost 1/5 of people mentioned the use of medicine to cope with their stress, and alcohol and smoking as well. And only less than 3% say that they talk to psychologists when they feel low for a long time. And there are big differences again between female and men respondents, especially when we talk about church. So church is more popular coping tactics among female, especially among elderly female. Medicine also more popular among women, and alcohol and smoking is more common for male respondents as well. So I have such a mixed presentation in the Ukrainian and in English. So we provide different recommendations, and we discussed it together with the UN Refugee Committee in Ukraine, then with the OCHR and World Health Organizations, because as I said, they're very much interested in such results, because they provide also training for family, for general practitioners in terms of mental health, and have some projects, especially in the eastern part of Ukraine, to support mental health of IDPs. So We provided different recommendations regarding institutional level, create stronger links between institutional support and that of the private sector, with inclusion of family doctors into the mental health provision sphere, introduce a licensing system for those undertaking psychological provision, bring together professionals and communities to develop innovative approaches in mental health care. And talking about the theme of this conference about digital aspects, I think that in terms of mental health, there are a lot of opportunities to develop it as well. And we applied for grant and wanted to introduce some accessible apps for general practitioners and for psychologists, which could help them to analyze and to quickly access some mental health issues of the patients. Unfortunately, we didn't receive funding, but we will keep trying. I know that there is an issue now with the big variety of applications for well-being and for mindfulness, and I think that it's also interesting here to explore how much is it popular in Ukraine, and then how much people use it, and are there any positive or negative aspects of it as well. It's important to ensure that gender and age specific approaches to supporting mental health are developed and well publicized. So the state to lead a cultural shift on reducing stigma around mental health issues, because from what we understood when we talked to psychologists and also with the IDPs, is that there is a big barrier to understand that, yes, I need help if I feel depressed for such a long time. So I think this I mentioned already about licensing. Yes, and the accessibility of mental health support is a big issue as well, because especially displaced people, and if you talk about elderly, they don't have money to pay for private services. But then if they, for example, just participate in a program and receive some free services, they need to be able to repeat it and to access it again. But then when project finishes, they don't have such opportunity, so they it's need to be considered as well. Yes, and again, need to talk about mental health in informational campaigns as well, and provide a lot of information, both for IDPs and for the general population. Thank you. I think that I will stop here, perhaps, just to have some questions and time.
Thank you very much, Irina. We really should not forget about this very disadvantaged group of people. Are there any questions to Irina? I have a quick one, Irina. I was very struck by the fact that only 2.8% of the refugees would think about addressing a psychologist. If there was one thing you could do to change that, what would that be?
I don't think that one thing can do it, because the issue is not only in of the low accessibility of mental health services for IDPs, but it's an issue for all country and for the general population as well. So it's just impossible to have project for one group of people, when it's neglected in a general level.
It's a global issue.
Окей. Я маю одне питання. Дуже гарно, пані Ірина. Мене цікавить, чи маєте ви онлайн-програми, такі як в нас онлайн-програми проти депресії і проти страхів? Чи є у вас такі, чи є в Україні вже такі онлайн-програми?
Are there online programs to treat emotional disorders?
Because we conducted our research 2 years ago, and on that time there were no, how to say, spread and accessible programs which would be mentioned by people and for doctors. So there are some small initiatives, but you know, on a big scale, I can't mention anything. So, but I would be happy to know more if I missed anything.
Вона не використовувала, але їй було б цікаво про більше дізнатися.
Дякую.
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 All right, thank you so much, Irina.
Can I just add?
Yeah.
I'm sorry, it just occurred to me because I'm just, Dennis, I'm going back to your question. What would be helpful to avoid stigma attached to psychology? Because myself, I'm a psychologist. I was really surprised to see very low, sort of very. So basically, not many people would consider to talk to psychologists. And I've been working with a number of Russian, Ukrainian speakers, and I've noticed that they're quite frightened of psychologists. They think that if you approach psychologists, it means something wrong with you. I don't know where it's coming from, but that's what's happening in reality. And I was thinking, because now in the UK, they try to change the way sort of they call psychologists or mental health professionals by saying well-being professionals. So I was thinking maybe just for people who suffer from anxiety, depression, maybe we need to use the language we use, mental health professionals or well-being professionals, someone who will give you some ideas how to use new coping strategies to deal with difficulties, mental health difficulties.
Absolutely, yes, I absolutely agree with you, because people really don't like the term psychologist because they associate it with psychiatrists and there's all the system. And therefore, one of the projects I have proposals, you know, rejected as well. So we sought to work with the artists, and you know, and together with artists, work with the elderly displaced people, you know, to walk through trauma, but don't call it art therapy, you know, but via storytelling and via some creative practices, you know, to work with these issues. Yes. So,
thank you so much, Lilian. Thank you, Irina. It's time for us to move on to the next presenter. It was a fascinating and really very interactive and important area.
Thank you.
So moving on to Dan Matsui, he'll be talking about something completely different, which really is talking about a novel approach to diagnosing disorders.
Hello. Thank you, Dennis. Can you hear me? Can you see my screen? All good?
Yes.
Yeah. So, good afternoon. My name is Dan, and I'm here today to share with you information and present one of the most rapidly growing medical technology. I'm really grateful to organizing committee for bringing us here today, and I'm really happy to present to you the pattern recognition of metabolites in human waste as a predictor of common diseases. So what are we going to cover today? I'm going to share the bird's eye view of the technology and approach per se. I will share some outstanding academic results along with market available applications. And of course, present our startup CareTech Human. So please make yourself comfortable and let's move on. A few words about myself, my story. In 2007, I was working on my PhD thesis dedicated to studying and developing nanomaterials for sensing application. I envisioned that application of these materials will be in space technology, supercomputers, spintronics, and many, many other industries. But it was hard to imagine that in 10 years, these materials will be already commercially available and I will utilize them while developing the medtech startup. In the period between 2010 and 2016, I've developed 3 startups which were successfully acquired by international companies. In 2017, 2018, I was working as the CEO of state-owned enterprise health responsible for digital transformation of primary healthcare level in Ukraine. And from 2018 till now, I am the CEO and founder of CareTech Human, and along with our team, we're developing the innovative technology for early disease detection and continuous monitoring. So, computers. Today we had really great speeches from other presenters, and I really enjoyed them. But in general, what are we trying to achieve with digital technologies? In my opinion, we're trying to make computers become alike humans. We've created technologies to teach them to recognize objects. It is called the computer vision. We teach them to understand human voice and languages. We teach them to analyze data and create insights. We teach them to assist us. We created technology to distinguish emotions, to understand when we are depressed, enthusiastic, dull, bored, angry, and so on. However, there is one area where computers are still less developed: orders. Despite a lot of efforts were made to integrate order sensors to computers, mainly they are all focused on security issues, giving information about certain gas concentration in the air. However, the overall progress allows us to create much more advanced order recognition technologies, and especially in healthcare. So orders and smells are known to be great source of information. It is well known that many diseases lead to specific smells of human waste, saliva, sweat. Even ancient Romans used dogs to diagnose some illnesses. And for instance, now dogs are being trained to sniff out COVID, and they are pretty successful with that. However, it is obvious that such approach has disadvantages. To understand how we can develop more technological approach, let's speak through scientific background. So, volatile organic compounds are end products of human metabolism, and these metabolites are perfect biomarkers. Generically, VOCs produced by bacteria are carbon-based molecules that are volatile at ambient temperature and pressure. These molecules belong to a wide spectrum of chemical classes, among which it is worth mentioning acids, alcohols, aldehydes, alkenes, aromatic compounds, esters, ketones, and nitrogen or sulfur-containing compounds. Now there are almost 2,000 well-known volatile organic compounds assigned from human body with sweat, blood, urine, feces. So volatile organic compounds metabolites are perfect biomarkers. On the slide, you can see disease map from human metabolome database. Each square represents a disease, and it is scaled by a number of metabolites mentioned in scientific literature associated with the disease. So as you can see, metabolites are well studied and linked to cancer, diabetes, liver, kidney, inflammatory, and other diseases. Volatile organic compounds can be very useful as the markers of diseases and helpful for clinicians, since its sampling is non-invasive, inexpensive, and painless. I'm going to talk through two main techniques or technologies to detect volatile organic compounds biomarkers. First one is gas chromatography mass spectroscopy, and second one is novel technology called e-nose or electronic nose or artificial nose. So GCMS technique are good for the identification of unknown volatile organic compounds from complex mixtures and for their quantification as well. GC has an excellent sensitivity within ppb range or lower and good reproducibility. In other words, GCMS method seems actually to be the most suitable for markers analysis and is considered as a gold standard. The utilization of GC technology you can see on the slide. However, in spite of miniaturization efforts, even if some transportable systems were manufactured, the most popular GC instrumentation still remains not portable and requires highly qualified staff for handling. They are relatively expensive and therefore suitable only for being used in some restricted clinical setups. There is a second approach to detect biomarkers. It is called the e-nose, or as I said, artificial nose. It works in the same manner as human olfaction system. We have nose, we have receptors, we have neural system, and we have brains. And we can teach brains to distinguish reflections from different objects. In the same manner, in-nose system work. And in-nose consists both of hardware and software components. Initially, gas is absorbed by the sensor area. The interaction with sensor provides signals which are collected in the data gathering stage. Subsequently, sufficient information is gained from the raw signal and transferred for processing. By teaching the AI system on the pattern recognition stage, it is possible to distinguish certain order partners and make a decision about gas composition. The biggest advantage of the in-nose technology is that it is detecting the integral response without having a need to distinguish certain molecules. And of course, it is times cheaper than GCMS and doesn't require any trained operator. It has to be said that in other areas, the in-nose technology is widely used for a decade, especially in environmental monitoring, agriculture and forestry, flavor detection, the food and beverage industries. But during recent years, a lot of examples of in-nose technology in medicine are noticed. As an example, I would like to share with you the results of scientific research of diabetes detection with in-nose. In this work, authors fabricated 6 chemical sensors employed in a portable in-nose device. Further, they performed tests with urine samples from 2 groups, namely type 2 diabetes and healthy subjects. To identify sensitivity and selectivity of in-nose system, the first test was performed towards 5 volatile organic compounds, which are particularly found in urine profiles of humans with type 2 diabetes. Second test was conducted with real urine samples from the volunteers. They used principal component analysis and cluster analysis to validate the obtained sensing response. As you can see there on the right down corner, they successfully split data sets of diabetes and healthy status. This and other similar findings suggest the possibility of using in-nose as an alternative, passive and non-invasive diagnostic tool for diseases detection, though analysis of volatile urine odors. So now a few words regarding our innovation. Well, when people ask me what it is about, to make fun, I always come up with simple allegory. So why do we see less broken cars on the street nowadays to compare to old days? Because modern cars, to compare to the one that you can see on the screen, they have very important function. It is called the check sign. It alerts the driver in advance that something wrong is happening with the car and either additional maintenance or diagnostic is needed. So we're creating check sign for human health. What is the problem? It is well reported that a lot of people in the world die annually from the diseases that are totally curable or totally preventive. The main reason why it happens is that people simply don't have a habit to perform screening tests meticulously, regularly. How can we solve it? By developing fully automated, accurate, and affordable home point of care, which will serve and which will provide regular and invisibly and regularly health check to a user. So how does it work? User simply unpack the device, connect it to the Wi-Fi network, and place it anywhere near the toilet where it is convenient. And mount small silicone pipe inside the toilet bowl. That's it. After that, every time a person urinates, device automatically takes the gas probe from the liquid level, analyze the data, transfer data to the cloud, where both AI and math algorithms, they look either for a specific biomarker or disease-related pattern. If this pattern or biomarker is observed systematically, a device sends an alert to a patient and his authorized doctor. And the doctor's role is to make decision regarding further steps. We have several strong competitive advantages. So we have very quick and simple installation. We have stable work without any replacement and any maintenance. We don't expect any human initiation, so we don't expect any actions from human side. We can detect multiple disorders by one device. We have high level of sensitivity and pretty good accuracy, and of course the cost is very, very low. So, sorry, a few words regarding our current status. So we've already developed prototype, and tested it. It means that we've tested all function like automative human detection, automative sample intake, and our technology to distinguish family members based on metabolic signature. We've already tested disease detection algorithms and verified them on real patients. We've studied a lot of diseases that are theoretically possible to detect with our solution, and now we're focused on screening and monitoring of diabetes and idiopathic ketonic hyperglycemia, which you know is a huge problem for 8% of kids up to 7 years old. And we have onboarded very strong advisors and implementation partners from Stanford University, from International Diabetes Foundation, from University of Kent. We have now 14 members of our core team, guys with proven expertise in AI, in big data, in medical device development, guys who develop devices which are now certified by FDA, so-called life critical med technologies. And the core team is supported with the advisory board from as I said, University of Kent, Stanford, and other organizations. So we're looking for opportunities to further work with doctors and healthcare workers to make our product market fit more accurate and to solve other related issues. So thank you, and looking forward to your questions.
Thank you very much, Dan. It's a fascinating presentation. I have an immediate question to you from my work, which is that in psychiatry, and psychologists and psychiatrists here will agree, we have a massive issue that antipsychotic medication that we give to our patients very often result in diabetes. Can you see your application to our patients to perhaps detect diabetes early, and the ones who have diabetes already to monitor how they are doing?
As far as I understood your question, you're asking about screening and early diabetes prevention, right?
But also monitoring for the ones who already have diabetes.
Yeah, we are mainly focused on two customer segments. So first one is people in the risk zone, those who doesn't have diabetes yet, but who are in the risk zone due to risk factors like age, weight, or high blood pressure, or relatives, etc. So we see our solution as a screening solution for these people. You know, I said it on the beginning of this conference, we want to create a fire alarm. Once you install it in your apartments, it have to work, fully automated way for years. And yes, and this is certainly one of our main customer segments. But on the other hand, we can deliver fully passive monitoring services, and this is the value which we would like to deliver to those who already have diabetes. Because as far as we discussed with doctors, the problem with the patient, they don't do glucose tests regularly, and of course it's painful. So we are trying to deliver non-invasive and fully passive way to monitor their diabetes.
Thank you. Then final question from Oksana.
Yes, thank you so much for your presentation. That's absolutely fascinating. And I just wanted to ask you, Do you see any opportunity in the future to develop a rapid express test, maybe for detecting COVID-19? As we know that you can either use it for detecting the changes in the upper respiratory tract volatile and compound, as well as human excrements volatile compound.
Thank you for your question. Very good question. You know, I don't want to play COVID card too much. That's why I'm silent about this in my presentation. But we've already tested it on COVID patient, and on Tuesday we're going to have further experiments in Boryspil near Kiev. So we're going to test like 20 patients with COVID and try to understand if we can detect, if we confirm again that we can detect the pattern in their urine. And of course, there are, regarding the second part of your question, yeah, we can also work with feces, but we just want to be focused on something, yeah, because there are a lot of diseases that we can target. But we're already developed the fully automated way to detect the urination moment, and our goal is to develop, as I said, fully automated solution. That is why we started with this, and further we'll add additional algorithms to detect new diseases.
Yeah. It's absolutely fascinating. Thank you very much. Thank you.
Thank you, Dan. Moving on to our final presenter today, it's my big pleasure to welcome Irina Rybinkina and her colleague, Lana Neela. Irina has been a member of our group for many, many years, and it's always a pleasure and a big inspiration to listen to what she has to say. Over to you, Irina.
Yeah, you just kicked me out, so I'm trying to reload the presentation as well. Thank you very much, guys. Just apologize for PowerPoint. Yes, browse, upload from my computer. Okay, sorry.
Now is a good time to crack a few Odessa jokes.
Yeah, yeah.
Do you know any fresh ones?
Unfortunately, Lana couldn't join us because she had to urgently go home to Crimea. So she's somewhere there, and there's no connection. So I apologize on her behalf. Save as. Sorry.
That's okay, Irina. I got a joke.
Yes, go on.
Go on.
I promise it's not. It's a PG. So Uber driver, the guy calls the Uber driver. It stops, and the Uber driver apologizes to the customer. Says, "Listen, I'm really sorry. It's really strong smell because I use a lot of detergent in order to make sure that the vehicle is safe for usage." And the customer goes, "Oh, don't worry. I for some reason lost smell yesterday, so it doesn't matter."
Well, that's a good joke in relation to Dan's presentation.
Oh, it says no files available. Upload from my computer. What is going on? Hold on.
Are you still cracking jokes? Who is?
Yes, Roman, go on.
Go on, Roman. Oh, is this this is somebody else cracking jokes?
Yeah,
Raising
Rui.
Rui, are you cracking jokes?
So why they call it the novel coronavirus?
Why?
It's a long story.
Maybe I can just screen share. Something is wrong. It's just not uploading it. Enable.
Wait, should we crack another one?
Go on, Rui, go on.
So, you know what they are saying about 2020?
No, what do they say about 2020?
You know, it went viral faster than anyone thought it would.
I think this is all the way down from this point, right?
Window desktop. Okay, does that work? What can you see?
It looks all right.
No, but can you see my screen?
Yeah.
Oh, excellent.
Yeah. Just, I would just say deny rather than open system preference.
Yeah, deny. Okay,
Yeah.
excellent. Now you can see. So thank you very much, guys, for.
Sorry, Roy. No further jokes, I'm afraid.
Yeah. Well, I stole that. My name is Irina Argentina. I'm an anaesthetist working in the UK. This is, I present a study that we are conducting currently which is funded by the Resuscitation Council UK, and it's looking in measuring emotional impact of national video CPR campaigns using artificial intelligence. Why did we come about to look into this? Just a few facts. There are 30,000 out-of-hospital cardiac arrests in the UK, and their survival is variable, and it depends on the location. There are only 30% of bystanders who initiate CPR, and as AEDs are now widely available in numbers rising, it is strange that no changes in surviving rates of out-of-hospital cardiac arrest. So when we looked into it, the main problem is with the public awareness or how to do CPR, and Resuscitation Council is trying to reach public through video content. So you would see a couple of main UK CPR video campaigns that have been circulating on TV channels, but unfortunately, usually they are not very successful. For example, the first video of Vinnie Jones, it was released in 2012 and only reached 250,000 views. In comparison to, for example, John Lewis' Christmas advert, I'll show you probably just one of them. It reached 10 million people in sort of a number of days or weeks. Why I'm showing it, because probably in Ukraine you haven't watched it, and I'll show you another little video of a CPR that we looked into. It's very short. And yet I'm still afraid to let it flow. What started out as friendship has grown stronger. I only wish I had the strength to let it show. And I can't fight this feeling anymore. I've forgotten what I started fighting for. And if I have to crawl upon the floor, come crashing through your door forever. 'Cause I can't fight this feeling anymore. Only a few seconds left. And even as I wonder, I'm keeping you in sight. You're a candle in the window on a cold, dark winter's night. And I'm getting closer than I ever thought I might. And I can't fight this feeling anymore. I've forgotten what I started fighting for. moving on. Hold on, sorry. It doesn't let me. Oh. Oh. So yes, in comparison to this video, which reached 10 million views, the CPR videos in UK usually reach averaging 300,000 views. So that's why we started looking into how we are going to modify our educational content. And considering the pandemic, a lot of it is happening via internet, Teams, online videos. And how we're going to look into how to improve resuscitation ads to improve the odds of survival. So why is it significant? The video can engage with a large audience and have a great impact. So some research in automobile industry and retail suggests that video with high emotional impact correlates with high social performance and shows great engagement and effect in consumers' behavior. So method that we used, we measured how people feel as they watch videos online through their webcam using a computer vision and artificial intelligence from a company that's called Realize. For the first stage of this study, we used a sample of 300 people of chosen UK target audience to examine each video, and the references I'll provide later. So we've recruited a sample and we've asked consumers to look at videos and answer some questions pre and post of watching them, and then analyze them and put them into this report. So what we were looking at is emotion metrics. So there are basic 7 emotions that we can display and that the computer and this artificial intelligence can detect. It's happiness, surprise, confusion, sadness, disgust, scare, and contempt. And beyond the basic 7, we looked at engagement, balance, and negativity. So considering attention metrics, so you can see the different so we were asking people when they were watching a video to have their web camera on and looking at the screen. So in the behavioral cues, we were looking, for example, for attention. They included eye movements, blinking, yawning, head movement. And then we used the score, 0 to 100 of a performance score, and I looked into the interest, engagement, and impact of each video. We also designed a survey, and I did a pre and post video survey that looked into sentiment analysis, favorability, sort of purchase intent, as with CPR videos, sort of whether they impacted the decision making or a view of a certain educational video impacted what they were going to do, and recognition and statement agreement. I just wanted to show you like a little video clip. There is an app that we used and how it actually detects any of an emotion. And excuse me, I was trying to demonstrate happy, confused, surprised, and how this program actually detects and what we are looking at. So for the first group A, we used 4 videos. I'm not going to demonstrate 4 of them, but just for the Ukrainian guys that you're watching, I don't know what you've got in Ukraine as one of the CPR campaigns. In the UK, just one of them, a just very quick one, is Vinnie Jones that probably everyone is familiar with, but unfortunately it wasn't that successful at its impact since its release.
My name's Vinnie Jones, and I'm going to teach you a lesson you'll never forget. There are times in life when being tough comes in handy. Say some geezer collapses in front of you. What do? We need a volunteer that ain't breathing. Here's one I made earlier. First thing you do is you check him over. If he ain't responsive or he ain't breathing or he's making noises like this, then his heart will stop working, he's having a cardiac arrest. Look lively. First call 999, then you do hands-only CPR and no kissing. You only kiss your missus on the lips. Watch, lock your fingers together, knuckles up, then push down, right on the sovereign. Push down 5 or 6 centimetres. That's about 2 inches in old money. Push hard and fast, about 2 times a second, like to the beat of staying alive. Worried you'll hurt him? Better a cracked rib than him kicking the bucket. Keep this up till the ambulance arrives. So don't forget, check him over. Call 999, push hard and fast to staying alive. It works. Hands only CPR. It ain't as hard as it looks. If you want to come in handy.
We'll move on from that. So I'm aware of the time that I've got left, only 4 minutes. I'm just going to quickly go through a summary and tell you what our next stage of the research would be. But if anyone is interested, I can sort of send my presentation over with all of the little minutiae analysis of every video that we used. So in summary, we looked at the population sample, and all 4 videos, they generated a good emotional response, and for the most part held viewers' attention. So looking at attention and emotions through the experience, all 4 videos, they produced emotion and attention levels in line with the primary educational global norm. So Learn CPR with Carol Smiley that we use evoke a positive emotion like happy rather than any other videos. The other video that we used was quite sort of abrupt and showed the Ville de Cune, Gore and Foskel video. I don't know if anyone's seen it, but I'll leave some links and you can have a look. Sort of this unsurprisingly given the melancholy nature of the video. The attention and engagement, I'm just going to scroll through this because probably I don't have time for this. Hold on. Yeah, so what about resuscitation videos in medical education? How can we improve them? The analysis of our research showed that basically it depends on the population that we want to engage, and it depends on what we're trying to achieve by educational videos. And resuscitation cancel UK cardiac arrest demo, for example, it's a mandatory part of an ALS course and it's available on YouTube, but it had only 70,000 views. And a video like Just a Routine Operation that probably all of the anesthetic colleagues know about, it is not mandatory, but it is reposted by many organizations and it has reached a view of about 500,000 views. So what we are doing next is conducting a second phase of the study. So we are launching it actually today. So the links would be available to 4 videos, and we're asking medical professionals, nurses, ODPs, doctors, anyone who can spare half an hour of their time to look at the study, to watch a video and give us and basically just fill in a simple questionnaire, and that would help us using artificial intelligence look into how we can improve educational content and reach more people using video content and improve the impact of every video resuscitation. Cancel makes just sorry, it's my son.
It's wonderful to have him.
Yes.
All right, Irina, thank you so much for your presentation. It's a worthy, highly worthy cause. This. Any questions? Maybe one or two very brief questions for Irina. Yes, Rui.
It's more of a comment. I wish I had known about your work 15 years ago when we were introducing robots for stroke rehabilitation, and we were asking. We had a questionnaire, and we asked professionals and so on. And one of the questions was, would you use a robot for rehabilitation? And we got 90% saying no. And then further down the line, we ask again the question in a different way, would you use a computer-assisted device for rehabilitation? And 70% said yes. So I think having a way of measuring not only the acceptance, but also engagement and attention levels to a therapeutic regime can potentially help you with the engagement issues that some therapies might be failing because of lack of engagement. So great work. Thank you.
Thank you. I just want to say that I think because of COVID, a lot of things are going to change, and we're sort of probably not going to normal as we know it for a long time. So we are trying to look into how the education can be delivered and how we can engage and impact the education of the younger population, not only with the CPR campaign, but for medical professionals. And I forgot to mention, you have a chance to win an iPad. So if you go on, there would be a chance of you guys, so some lucky person to win an iPad. And we will even send it to Ukraine.
Wonderful. Thank you so much for this. Just quickly check if there are any further questions.
I think there's something in there.
I can't see any more.
Okay.
So with that, I just wanted to thank you so much, Irina, for your wonderful and really important public health work. I'll just hand you over back to Roman for final remarks, and I think a very brief presentation from a colleague in the last few minutes.
Yes, Irina, greetings and delighted to hear all the background noises. It's such a refreshing and pleasant development when we do these things online, and it just gives you a bit of personal background to where we are and what we're doing. With the permission, Oksana Sota requested that she could perhaps update us and contribute to this fruitful conversation. So I do hope that the audience will not mind, and welcome, Oksana, and please, I'll pass the microphone over to you for a brief update. I'm not sure what this is about, but I'm sure it'll be outstandingly interesting and relevant. So with that in mind, Oksana, please.
I hope very relevant. Thank you so much, Roman. First of all, I want to thank you very much for all of you guys. I'm an old member of the British Ukrainian Medical Association, and I'm greeting you today from Switzerland. And so I very, very happy that Dennis reminded me at the last minute about the conference, because otherwise I would miss it. And I'm so happy that I'm part of this conference today, and absolutely outstanding speakers. And almost every one of you, every speaker brought some issues that is absolutely relevant to the current time, to the time of COVID-19 pandemic. And so I do have some suggestions. As I am working at the moment on a comparative study of application, COVID-19 application in different European countries, and to bring such a subject impromptu to our gathering, I think it would be not wise. Because it's very specific and takes a lot of time. And but I would suggest, what you think? Could we organize? I volunteer to organize, co-organize, or facilitate our next Zoom meeting on to dedicate totally to the artificial intelligence application use for COVID-19 test and trace in different countries. So I think it would be very interesting for the UK, the experience we have here in Switzerland, and to compare two systems. We have two different systems. We have national healthcare in UK, and we have the private healthcare in Switzerland. Switzerland was the country who developed one of the first in Europe take a test and trace application, and our application, Swiss one and UK one, very different. Swiss one based on decentralized carrier, and UK started as a centralized one. Then it been changed a bit. So I think this would be really, really interesting. And if you agree, we can discuss how to move forward. And if it is interesting, I would be very happy to facilitate this meeting. Hello?
Thank you, Oksana, and thank you for your obviously relevant update. And I think it would be a great opportunity to consider it, and perhaps we can continue this discussion about this proposition in the offline regime. Yeah. And certainly if we can facilitate it and open a forum, yeah. Then MS Teams is the limit. There's no limit. Thank you, Oksana. Well, I genuinely don't want to have the last word in this meeting, which was interesting. It was new. Some stats. Our YouTube channel received first like. I'm really proud of it. We've achieved this about 10 minutes ago, so that's amazing. And it was viewed by 32 people, the first part, and then lunch followed by 12 people, and we had to change the link, so that probably reduced the activities online, but it will be available for viewing later on. And it's an opportunity for us to create a perhaps database of presentations that are of some relevance to the colleagues who weren't able to join us. I would like to just say thank you to everyone who participated for your contribution. If anyone would like to comment anything, then please, this is your opportunity. I know Rui rejoined us and he wanted to say something for the closing remarks. Rui, are you still with us?
Yes, I am. And I would just like to say thank you for the invitation. I think I really enjoyed the presentation. Sorry, I missed one, I think.
Can I stop you here? Irina, you're doing something and you're still sharing your screen.
Oh,
I'm
sorry.
inspired to see what you're doing, but I think it breaches some confidentiality clauses.
Sorry,
and it's been recorded as well, so oh my God.
No.
All right. I just realized it, so apologies. But yeah, please stop sharing your screen. Rui, apologies, over to you.
That's okay. So I just wanted to say thank you for the invitation. I really enjoyed meeting you all and listening to the other speakers. So I learned a lot today, and I just want to wish you all the very best. And also an open invitation. So if you'd like to come and see what we're doing, not that we can now due to lockdown, but when things get better, please do get in touch.
Thank you, Rui. Would anyone else from the audience and participants wish to share any comments or suggestions or anything else? In which case, I would like to pass. Oh, Roman, please. Roman G.
I would like to thank you, everyone, and especially organizer, Dr. Roman Uhrin and Dr. Roman Krech and Dr. Denis Uhrin, and especially Anna Tarasenko for organizing such a beautiful conference. And thanks everybody for participating and stay. This is the first time we organize online this conversation, and I think it's went really beautiful. So thanks everyone for joining, and especially for organizing this conference. Thank you.
Thank you, Roman. And thank you to you as well for all your patience and your troubleshooting when we were putting together this streaming service. But I think it's well deserved for me to pass the final closing remarks to Dennis, who essentially was the organizer of this conference, and he put together a fantastic team of young individuals who assisted us with putting it together. So Dennis, please, over to you for the closing remarks.
Yeah, I'll just say very briefly that it's been 11 years. It's not like 11 days or 11 months. We've survived despite COVID, despite all kinds Brexit and all kinds of other events that have occurred in the meantime. I really wanted to thank Roman for his leadership. It's something that is not an easy task to herd Ukrainians, which, it's kittens will be a significant understatement in comparison to us. And really for the young people who helped to organize, for Sofia Hrushkevich, for especially for Sofia Hrushkevich and Marta Fetzig, who are the youngest members of our team, and then for Anna, who did the bulk of the work and the beautiful design, and also presented something really very interesting. And for everybody who participated, we are a small community, but Roman assures us that we are, I think, the second most active medical community outside of Ukraine. And so with that possibly somewhat false knowledge, I'd like to leave you and invite you to our future meetings, which usually occur around this time, October and November every year.
Okay. Ще раз вітання з Німеччини. Дуже дякуємо за запрошення. Це було, звичайно, несподіванка для нас. 3-4 тижні я отримала від Дениса запрошення. Дякую. Ми коротенько так підготовили свою нашу доповідь. Надіємося, що наша співпраця буде далі продовжуватися, і ми запрошуємо вас до нас тоді до зустрічі.
Ви думаєте, що німецьке товариство активніше, ніж британське, чи не таке активне? Чи ми будемо вірити Романові, що ми друга найактивніша громада?
Ми так само сказали, що так само поговорили коротенько з президентом, з Андрієм Батрухом, що ми беремо від вас приклад і будемо так само робити такі величезні конференції і залучати людей наших до таких конференцій. Дякую. І всього вам найкращого.
Дякую вам за ваш час. So I think with that, just wanted to thank everybody and hope to see you soon.
Bye, everyone.
Bye, guys.
Bye-bye.
Thank you so much, and I'll see you later. See you soon in real life. Okay. Bye-bye.
Bye.
Thank you very much, Dennis.
Thank you.
Thank you.
Thank you so much.
Bye, Оксана.
Bye.
До побачення.
Thank you.
Bye.